What an exciting day for space junkies, for anybody who loves aviation or astronautics or just the atmosphere or space or just the excitement of people doing something that very few people in the world ever get to do. Well, this morning we had the launch of the Blue Origin New Shepard spacecraft. Now, there are a lot of different private companies. Remember, there was a day when it used to just be NASA for American spaceflight. Now we have private spaceflight companies like SpaceX and like Blue Origin, and Virgin Galactic, I guess, is British technically. But this is a look at the Blue Origin spacecraft. Now, the way it works is that you have a capsule on top where all of the people are, 6 women, by the way. And then this is the part of the rocket that holds all the fuel. And then obviously the thrust comes out of the back of it. And when they get up high enough, the rocket itself detaches from the capsule, and then the capsule will just be in free fall. And the rocket actually landed itself, which was pretty amazing. So let me give you some information, and then I want to talk about some questions. What is space? Did they actually make it to space? And you know, what constitutes space exactly? And also, what does it mean to be weightless? So there are a lot of misconceptions about this. So did they really go to space? Does space make them weightless? Did space make them weightless? We're going to talk about that. So the people who were on the flight included Katy Perry, you know her, pop singer, Gayle King, who is a TV host and also known as being Oprah's best friend, Lauren Sanchez, who was actually a news anchor in Seattle before she met and got engaged to Jeff Bezos, who owns the Blue Origin. Aisha Bowe is an aerospace engineer. Amanda Wynn is a civil rights activist, and Carrie Ann Flynn is a film producer. Now, in all, they were only in the rocket for about a 10-minute flight. I think it was like 10 or 11 minutes. And so that begs the question, well, how in the world could they have gone to space? This is a view from the ground, by the way. I mean, that's how high up they were. How could they have gone to space and gotten back home in 11 minutes? Like, how is that possible? Well, it has to do with the difference between going to space and going to orbit. Big, big difference between just touching space, which is what they did, and they did, versus being in orbit. Let me click on a different video here because this video was pretty cool. I don't know what, there we go. What they did was they did not enter orbit. They took off from West Texas and they landed in West Texas. So they kind of went straight up and down, as opposed to what Sonny and Butch did, you know, and what all the astronauts in the ISS do, which is, and I'll explain it here in a minute, which is they go a lot faster and they orbit the Earth, you know, obviously for a long, long time. So the spacecraft, the rocket, traveled upward at about a maximum speed of 2,200 miles per hour, which is about 3 times the speed of sound. So let's answer a couple of questions here for you that you might be wondering. Maybe you are, maybe you aren't wondering. I'm going to turn off my ring light here because you can see it, and I don't like that. That doesn't make me happy. So here we go. So hopefully you can see that pretty well. So let's talk about the first question, which is, did they really go to space? And the answer is yes, they did. Now, again, you may be wondering, like, well, how in the world are people up there for weeks, months at the space station? You know, how did Katy Perry go to space in 11 minutes? Well, it has to do with the definition of space. So there are 2 definitions of space. One is kept by the International Astronomical Foundation, which is actually it's the International Foundation, which is based in Europe. It's in French, okay? But that's what it translates to in English, is the International Astronomical Foundation. And they are the ones that, for example, will decide if you made it to space. Like, let's say you wanted to set a record. Let's say you rode on 5 SpaceX flights or something, or 5 Blue Origin flights, and one of them you only got it up to a certain height. well, then they wouldn't give you credit for the record. You see what I'm saying? So their definition is called the Kármán line. Kármán. This guy has two accents in his name. He was Hungarian. Kármán. And he was an early aeronautical engineer and did a lot of work on rocket ships and developing the technology of aircraft and things like that, supersonic aircraft, and then what they call like hypersonic aircraft, which have to fly really high in the atmosphere and go, obviously, way faster than the speed of sound. So they call it the Kármán line. So they named it after him in his honor. He died a long time ago, early 60s, I think. So the Kármán line is 100 kilometers. 100 km, which is also 62 miles above the surface of the Earth. So if you are in a rocket ship and if you make it 62 miles up, you are officially in space. The United States, though, has a little bit of a different view. So let's do the good old USA. Okay? USA says 50 miles. So it's not as if there's a magic moment that you're in space. And that brings me actually to question number 2 about the weightlessness. It's not as if you have escaped Earth and now you're in space and now everything's floating around. It doesn't work that way, which I'll explain. So did they make it to space? Well, as long as they made it to 100 kilometers, which Blue Origin says they did, then yes, indeed, they did make it to space. Why is that considered space? Okay, why? Well, because you have an atmosphere around the Earth. Outside the atmosphere, we have space. So let's draw the Earth here. I'm just going to draw the surface of the Earth like this. Okay, so there's our Earth. And the lowest layer, and this is not drawn to scale, because if I was drawing it to scale, I would be too thin. So let's say this first layer right here is called the troposphere. T-R-O-P-O-S-P-H-E-R-E. Troposphere. It comes from the word like tropics, which is like temperature. Anyway, the troposphere is where all weather happens. So this is where we live. This is where weather happens. It's where we live, life. Anything that you've ever experienced in your whole life is in the troposphere. That's where we have breathable air. If you go up too high in the troposphere, then you can't breathe and you get apoxia. Like if you climb to the top of Mount Everest, you're still in the troposphere, but you can't breathe. There's not enough oxygen. Above the troposphere is a layer called the stratosphere. Strato, S-P-H-E-R-E. The stratosphere, which, by the way, the Fender Stratocaster is named for the stratosphere. And I think they did it because like when they invented the electric guitar in the 1950s, and when Fender started making guitars in the late 50s, it was like the space age, and everything was named after like spacey kind of stuff. Like you had Buck Rogers and all this stuff. And so they named it the Stratocaster. It sounded like stratosphere. Anyway, and now it's a legendary guitar. So what happens in the stratosphere? Well, in the stratosphere, okay, so here's what's interesting is that in the troposphere, you're warm. That's going to be too small for you to see. But you're warm at the bottom and you get cold on top. The stratosphere, you're cold at the bottom and you get warm on top. So why is that? Cold, warm. It happens because of the ozone layer. That's what's in the stratosphere. Ozone. O-Z-O-N-E. When ozone is in the troposphere, it's bad because it's a lung irritant. You'll hear me talk about that when we have ozone watches and things like that. It's an irritant, but it's very, very important in the stratosphere, and I think you know why. Because it protects us from UV rays. The ultraviolet rays from the sun would otherwise come in and just, I mean, we would not be able to live, actually, not just humans, but other animals too. So the ozone layer interferes with the UV rays coming through, and it creates oxygen, and it kind of knocks off one single oxygen molecule. That's why the refrigerants that we used to use caused so many problems with the ozone layer, because it affected the knocking off of the oxygen atom. Anyway, that's the stratosphere. So the rocket made it through here, okay? I'm not going to draw the Blue Origin rocket either, and don't even ask me why. Don't even ask, okay? So there's our rocket. Let's just say this is our rocket, and it's going up. And next, after the stratosphere, is the mesosphere, okay? Not much happens that you need to worry about in the mesosphere. There's nothing that happens that we would see or even know about in the mesosphere. There are a lot of important things that happen with physics that happen in the mesosphere, like, you know, you have cosmic rays coming in and things like that. Also, by the way, it gets very hot at the bottom, and then it gets colder at the top until you get out to the ionosphere, when it can get extremely hot. But the bottom line is this, that this ends here at about, let's see, the top of this is about, do you want me to put it in kilometers or miles? Let's see, it's about 10 kilometers is the top of the troposphere. The top of the stratosphere, let's say, is like 50 kilometers-ish. And then the top of this is something like maybe 90 kilometers. Give or take, give or take. So what happens is that the rocket ship here went outside of the mesosphere. Once you're outside of the mesosphere, there are so few air molecules that you're considered to be in space. So this is going to be considered space. Now, there are still atmospheric particles out there, like the aurora, you know, the aurora, like the northern lights and the southern lights and everything happen out here. But you really don't have any air or atmosphere per se. So the rocket cleared the troposphere, cleared the stratosphere, cleared the mesosphere. They went up. They were in free fall. That's the weightlessness. They were in free fall. And then the parachutes came out and slowed them down considerably. And then they landed back on the ground there in the troposphere. And the whole thing only took 11 minutes. So why were they able to do this in 11 minutes and everybody else, it takes them weeks or months? Well, it has to do with what kind of flight they were in. So let's just say that this is the flat. Here's West Texas, okay? I'm going to draw a cactus. That's my cactus. Anyway, so there's West Texas. We'll have a longhorn out there somewhere. So the rocket launched, okay? It came to a point where it didn't have thrust anymore, so it broke away from the rocket. It stopped here, and everything like that takes what's called a parabolic path, which goes like this, okay? So it goes up here, and then they start falling. And then they go down, 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 and then you have these parachutes that come out, you know, like that. And the little capsule here safely hits the ground. The whole thing only takes 11 minutes. So how is that different from what happens with all the other rockets we see? Well, the other rockets are totally different. You have the Earth. And here's the equator. Now, at some point on the Earth, and you could do it anywhere, but it makes sense to do it in Florida. So we're just going to put Florida, you know, we'll just put a dot there. That's where Florida is, okay? Because you don't want me to have to draw maps all over this. The Earth spins, okay, this way. The Earth is spinning around, right? How fast does it spin? Once per day. Okay, one time per day, one rotation per day, which means that at the equator, the Earth is spinning at over 1,000 miles per hour through space. So the surface of the Earth is spinning really, really, really fast. So if you can catch some of that speed and your rocket goes this way, now you're going to get the power of your rocket engines that are making you go faster and faster and faster. You also got like a head start by being on the Earth. And then the next thing you know, you are in orbit. Now I'm going to turn the Earth on its side. So here's the Earth kind of on its, I'm just going to draw it on its side. So now you are in orbit. You're not in orbit around the poles, but I'm just kind of drawing it like this. So here's Earth. And here's you. And you're in orbit around the Earth, near Earth orbit, about 250 miles. So much higher than the 62 miles that the Blue Origin folks were above the ground. Now, granted, this is a little bit misleading because this is not the North Pole and the South Pole. The way the orbit is set up is that the vast, vast majority of the time, if this is the Earth, there's a North Pole and the South Pole, the orbit is going to be like this, you know, and it's going to go around like this, and then it's going to go around the planet and come back over here. So you're going to go like that, or something very close to it. So this is orbit, okay? Orbit, which is much different from what happened with Gail King and Lauren Sanchez and everybody who went up in the Blue Origin today. So that's why. Now this, they stay up for weeks. I mean, minimum they're up there for like 7 days or 8 days. Sometimes they're up there for many months. Also, by the way, this is where there are literally thousands of satellites going around the Earth. You have some of them that go around like this, okay? And they never land. And you have some of them go around like this, and you have all these, I mean, they're everywhere. So those are the ones that are, once they're in orbit, you're out there in orbit. And as long as nothing goes wrong, nothing catastrophic, you have weather satellites that are like way out here, and they all stay in orbit. So it's much different than the Blue Origin flight. Now, I want to talk about weightlessness. This is a huge misconception. Huge. Huge. Okay? Huge myth. The myth is that space, that people are weightless in space. It's not true, okay? There's nothing that happens in space that all of a sudden makes you weightless. Weightlessness happens when you are not feeling the sensation of anything pushing up against your feet, okay? That's how you feel weight. So remember, like back in school, you have mass and weight. So mass is how much matter you have. Weight is how much the Earth is pulling on you. If you were on Jupiter, you would weigh a lot more, right? And if you're on the moon, you weigh a lot less, which is why the astronauts can sort of hop around on the moon, right? So there is gravity there. It's just that you're standing on something that doesn't have as much of a gravitational pull. So imagine this, okay? This is why they were weightless when they were not in space. So here you are in the space capsule. Space capsule looks something like this. That's the way I'm going to draw it. Okay? You're falling. So you've made it to the top. The rocket ship has gone away, and now you're falling. Okay? You are in free fall. Now, all the people in here are floating. Okay? All these ladies. There's Katy Perry. There's Lauren Sanchez. They're all floating. Okay? And they're having, let's say they're having a good time. All right? That's weightlessness. Astronauts can train for weightlessness in an airplane. They call it the vomit comet. The airplane makes all these, they call them parabolic, waves. It goes up, and when it hits the top, they go weightless. And when they're going around like this, they're weightless. And then when they hit the bottom, you feel more G's. So weightless just means that there's 0 G. So the floor is not pushing up on them. They're falling. They're weightless. They would be weightless even if the ground was right there. They would still feel weightlessness. Obviously, we don't want them to crash into the ground. That's a catastrophe, which is why they have the parachutes. But while you're falling, imagine, this is what Einstein imagined, okay? Einstein said, if you were in a box, okay, and you're just in the middle of space, and if you couldn't look out the window or anything, you don't have any windows, you would have no way of telling if you were falling toward a planet or if you were just floating out in space. It would be the exact same sensation. By the same token, if you had a rocket ship, let's put rockets there, and you have these flames coming out of it, right? I mean, I think that's kind of what rockets look like. I don't know. That's in my mind, that's what rockets look like. Now you're like this, and the floor is pushing up on you. So as long as you kept those rockets accelerating, as long as you kept getting faster, 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 and you had no windows, you would not be able to tell the difference between if you were in a box on a rocket ship or a box standing on the Earth or a planet. Because it's just a matter of how hard those things are pushing up against your feet where you're standing, pulling you down. So that's weight. So if you took these away and you imagine that you're Katy Perry and you are just there falling, the box is falling and you're falling. So this is falling, Katy Perry's falling, everything's falling at the exact same rate. You do not have to be in space to be weightless. The example I gave in our news meeting, I think scared some people. And the example was, if you were in an elevator at the top of the Williams Tower, God forbid, and somebody, some evil person, scoundrel, cut the cable that holds the elevator. Well, what's going to happen? Your elevator is going to fall, and you're going to fall. The elevator and you are going to fall at the exact same rate. So what happens? You're weightless. You're experiencing 0 Gs. That is a 0 G environment. You're weightless. Now, of course, you're not going to be weightless for long, because eventually you're going to run out of space and you're going to hit the bottom, which we would never want to happen. But the bottom line is, during that fall, you're feeling the exact same thing as all of those astronauts did when they were falling back to Earth. So it doesn't have anything to do with space itself. So then the next logical question is, well, Mike, what about the astronauts at the space station, or when they used to be in the space shuttle? Weren't they floating around weightless? Yes, because when you're in orbit, you're actually falling, but you're moving sideways so fast that you're falling around the outside of the Earth. You're in constant falling, but you're moving sideways so fast that you're going over the curvature of the Earth, and you just keep doing that. That's how you stay in orbit. So you're not going to feel gravity. There are thoughts that if we ever had a space station that people lived in for a long time, you've probably seen this, like I think it was in 2001, Space Odyssey, where you have this huge circle, and you would get it rotating, and it would rotate at the correct rotation speed to make it feel like you're experiencing 1 G, 1 gravitational sort of value of Earth. And then you could walk around, and you would not be able to sense the difference between you walking on this spinning thing in space versus standing on the Earth. Gravity would feel exactly the same, and you would no longer feel weightless. So that's the deal, guys. So the bottom line is it is confusing, but space does not make you weightless. Being in orbit will make you feel 0 Gs. Okay. The last thing I think I'll say, maybe this is one more thing will make you think about it, is, fighter pilots. You know how they'll say, they have the stick, and if you make a hard turn, they'll say you pulled 5 Gs. And it, like, all the blood comes out of your brain. You know what I mean? When these F-16s or F-18s are making these, hard turns, they say, oh, 5 Gs. Well, you can also have negative Gs, right? So when you make that turn like that, you might be experiencing 5 Gs. Nothing is increasing the gravity of the Earth. You're not weighing more. It feels like you're weighing more, right? Your mass you didn't get, you didn't like eat too many ice cream pops like I do, right? You turned the airplane. So it's the same thing. If the airplane went into a nosedive, you would be weightless. And then you have to pull up before you hit the ground. So anyway, that'll do it for Mondays with Mike, guys. I love this stuff. Love, love, love this stuff. I hope I didn't get too convoluted about it. But the bottom line is there's just such a myth that space has no gravity and the Earth does have gravity. There's gravity everywhere. It's all relative to where you are. Thanks so much for tuning in, and shout out to my mom and Neil in South Florida. I'll see you all next time.